Here is the relay. This is a 14-pin relay. You can see the 12 contact points are there, and 2 are for coil. And this relay, you can see, this is from a company which is known as Kenji or something like that, from China, of course. And what is written is contact 5 ampere 240 volt AC, then 5 ampere 28 volt DC, and this is the relay company name, Kenji, of course. So this is, and on the coil, if you will see, this detail is actually for the contacts. Contact detail has been given over here. And for the coil, if you are about to know what is the coil voltage, because coil needs a voltage to operate this relay, coil needs, of course, 220 volt AC. You can see inside it is written on the coil. So normally they are mentioning the coil voltage on the coil. So it is written on the coil 200 to 240 volt or 220 volt AC, of course, over here on this coil. So what is this relay is actually, if we will provide a 240 volt or 220 volt to these two terminals coil, so this will internally, this will make switching. And how this will make switching inside, if you will be able to see, there are normally closed and normally open contacts, and the center one is common. So these are through these wires. You can see these white wires, they put it in these 2 wires this side and 2 wires this side. These wires are coming to these 4 contacts here. These are the common contacts for this relay, and of course these are the normally closed. While there is no power to the coil, this is off. That moment these contacts are connected to these contacts. So while we will provide power over here 220 volt, they will be switched inside, and these normally open contacts will make contact to these common. This is what we are going to use in the circuit, these relays. Now, most people, they know about the function of the relay, but for the most new people, the relays are confusing, because while they are looking at these points, they are too many points are there, 12 points or something like that, or sometimes they are more, sometimes they are less. So then they are confusing, and they are not understanding what these boxes are doing. So this is what is the purpose which I explained to you. And what they are doing is actually, for me, I mean, what I will be doing with this relay is this fan. You can see, just I'm going to connect this to the battery. Here is the switch for this fan, and this switch is, as you can see, this is actually a 250 volt and 15 ampere, but I am going to connect it to the battery. This is a battery fan, actually 12 volt DC fan. So this switch is in the one wire. As you can see, one wire is directly coupled or connected. This one wire is connected directly together, and the other wire has a switch, this switch. You can see, while I'm switching off, the fan is going to be off, and while I'm switching on, the fan is going to be switched on, like this. Okay, so this is, so this function, as we are switching on and off by my finger, by my thumb, actually I can switch an on and off, or by my finger I can switch it on and off. I can do it with a relay. So what I'm doing is I am substituting this switch with this relay. So what will be the benefit is I'm making an automatic switching. Automatic switching, how that while there will be electricity, I mean the house electricity, 220 volt will come, this fan will be switched off, because that time I'm using the 220 volt fan instead of 12 volt. So while the electricity will not be there, I mean the load shedding time, there will be no power over here on this coil, and we will switch on that fan through this relay. So what we will do is we will be using these contacts, normally closed contacts, with a common contact set, and we will create a circuit so that it will do our job automatically. So how the circuit diagram will be, I'm going to explain a little bit on the paper so that you will understand it well. It will be like this, that 220 volt, which is coming, the mains is coming, 220 volt phase and neutral, they will come to this relay coil, and relay coil is of course these two terminals which are over here, and then there is no connection of these 220 volt to the contacts. keep this in mind, new people, that these other terminals, they have no connection to these. These are separate. These are only the coil terminals. Then what we will do is we will be using this normally closed contact to the common. This is common and this is normally closed, the upper one. These we will be using with our battery. So we will connect our battery over here, and then from here to here we will connect our fan some way like this. This will be our 12-volt battery. Positive or negative, there is no change. I mean to say, this is a relay, this is a common switch, so there is no difference whether we are connecting positive over here or negative over here. This is making no difference. But for the fan, of course, it is making a difference, because the fan will be reversed then. So when the power will be there, this will be switched off, because this coil will make a magnet, and that will pull this common contact away from this NC, and it will make a contact with the NO, but NO we are not using. So then the fan will not run, because the circuit will be opened. And when we will connect, we will not have the mains, then the fan, these normally closed and common will be connected together, and the fan will run, because the circuit will make some way like this, so the fan will run. So this is what we are going to make practically. To making this, we need 2 wires for the battery. I mean, these 2 small wires we are going to connect, but you need a thick gauge wire, because DC power is involved. Many amperes, say 4 to 5 amperes or 10 amperes are involved for the fan. So we are going to use these thicker wires. And the other consideration is we have to use all the terminals. All the 4 terminals we will incorporate, all the 4 contacts. We will not keep any contact without soldering. So this is the way. Now I'm going to solder this. For the soldering, first what we have to do is we have to make a little bit fluxing on the terminals. This is the colophony or the rosin. I'm going to make fluxing on these terminals so that they will be easily soldered. This is what is the requirement, and also it will be perfect soldering then. Some people are not using the flux, but the use of flux is good for the soldering, especially if you are going to make big soldering work like this, so the flux is better. Then I have to tin these terminals, so then it will be easy. They are already tinned actually, but a little more tinning will be effective, and it will do better. Actually, a socket is available for these such relays, but these sockets are not very common in the market, and they are expensive also. So that's why I am recommending you people to make soldering, so the soldering will do your work very perfect. It will do same way like a socket can do. But in this situation, the relay replacement will not be easy. The socket work, the sockets are normally used in industrial work, because there we need frequent replacement of the relay, which is not, in our case, which is not, I mean to say, required. So I'm going to flux this wire again, the other wire which I'm using to make the other contact with, the other set of contacts. I mean, I'm going to solder with this wire. Again, a little more fluxing for the common. Better if I will tin them first. It will make a better job then. care is required. There should be no dry solder with any of the contacts, so that it will not make any problem with the current densities, something like that. So this is what we did. The central points we did not touch because they are the normally closed, normally open. We are not going to touch. Instead, normally closed and common. These are our terminals. Now is the time to make the 220 volt connection. For the 220 volt connection, what we will be using is, we are using this cable. So these two wires, I bare them, the conductors, and then I will be using a piece of sleeving, a glass sleeve, and even you can use a shrinking sleeve, anything which is your desire. You can use. I'm using normally these glass sleeves. I'm comfortable with. So these two pieces, just I'm putting on something like this, and then you should have to pass these wires through these contacts if they can. If we are able to do it, we will do it. Otherwise, we will be soldering it in the regular manner. So the second one was perfect, but the first one was not perfect, so we will try it to make it even better, because 220 volt is involved, so we will take care. The wires should not be spread here and there. Or we can make it perfect soldering so that the wires will not spread. Now we will flux them, these wires, together with the terminals. Then we will solder these two terminals also, the coil, of course. So make it straight, better. Some will like this. Check your work. If they are soldering properly, it's okay. Otherwise, solder them with care, and also remove any residue soldering. Now we will put these sleeves on the top of these connections, so that if anybody will touch accidentally, he will not be electrocuted or will not be shocked, something like this. And also we will put insulation tape on, because safety is the first measure. That is important. Now is the time to cut this off. These two wires, I just cut them because this was one wire, and these two connections for 220 volt I am making. So strip the wire insulation a little bit, and now is the time to fix this plug, this male plug, so then it will be easy to put in the electrical system. Just pass them like this, twist them together, twist them once again to put them in, and using a small screwdriver I can open these two screws. Opened it too much, it's okay. Now we will not grab the insulation in the screw, instead we will grab the conductors in, so that it will be connected perfectly. Make sure like this. Sometimes we are grabbing just insulation and the connection is not making inside, which is something, an undesired thing. So tight it firmly, something like that. It's okay. And now we will put this in, and the top also we will have to put it on. Nut is there, you can see. The screw we will put it from here and then we'll tighten it using our screwdriver. It's okay. Now is the time to test it. So testing we will make using 220 volt as well as with a meter. So with a meter what we will do is we should have to make the meter on continuity or ohm range. Ohm range is better. So we will be able to check the ohms for this coil. They will be high ohm, of course. So you can see 3.46 kilo ohm, 13.46 kilo ohm, 13.46 kilo ohm. Okay, and now we will be using the continuity to check the continuity. Continuity should be there. As you can see, continuity is there. And while we will put this in electricity, the continuity will not be there. We are going to check this thing now in electricity. Here is our power, 220 volt. We will not put this in power. Instead, we will put this in power and we'll check. So just see, this is in my hand now, like this. You can hear the clicking as well as you can see this LED. LED is coming on and the clicking is there and the switch is changed. You can see inside, and now it is changing the state. So something like this. If we will put it on the battery, I'm just going to show you how to connect it to the fan. This is for new buyers actually, that's why. We will remove the fan connection from the battery and put this connection on the battery terminal as well. Then we will connect this fan cable to the remaining wire. So this has been come in the way. Hope you will see the circuit, it will be clear. Now the fan should run. As you can see, the fan is running because we are out of the power. There is no power to the relay, so the fan is running. And now if we will put this in the 220 volt power, I'm just going to show you the power. The fan will be stopped. So you can see now the fan had been stopped and the relay had switched this fan off. Now we are going to remove it again, as I am simulating that the electricity is going to be off from the company. Now the fan will start. The 12 volt fan should start. So as you can see, I just removed and the 12 volt fan had been started. So this switching is made over there inside the relay. Again, now it's off. While the power is there, it is off. So this is automatic. So this is actually the requirement is of my father. He was about to make a circuit that in the night one should not wake up to switch on and off the fan while the electricity is coming and going. So for this purpose I made this. Hope you people had been enjoyed this relay connections and everything. I mean, new people had been learned something, and old people, of course, they have good learning for such system. So keep on watching. Please subscribe the channel and like the video.